All right, we're back. We are still on page 88 of math analysis. We're basically just solving problems together at this point. So, if you think you can solve all these on your own and you can check them on your calculator, like go do it. Otherwise, hang out and let's solve some problems. So I'm gonna do U substitution on this. U is gonna be x over 2 plus pi over 3. And then, so if x is equal to 0, then U is gonna be pi over 3. And if x is 5 pi, then U will be 5 pi over 2 plus pi over 3. I'm going to have to write that. 5 pi over 2 plus pi over 3, which is 15, 17 pi over 6. All right. So then our problem becomes the tangent of U is radical 3 over 3. All right, so what kind of angles are those? Those are going to be pi over 6 angles. So I'm going to rewrite this as 2 pi over 6 so that I can then write my bounds as 2 pi over 6 less than or equal to U less than or equal to, conveniently, that one was already over 6, 17 pi over 6. All right, so then we just got to think about them. So where's the first one? First one, so it's pi over 6 angles. I don't know what I'm saying. U is equal to, I think what I was going to say is like the first angle where this happens is not in the interval, but I'm going to write it anyway and just cross it out. Pi over 6. The next time that happens is in quadrant 3, which is pi away, so 7 pi over 6. And then if I add pi, so in this case, you don't need to do the leapfrog thing. You can just keep adding pi, which is 6 pi over 6. So this will be 13 pi over 6. And then if I try to do it again, I'll get 19 pi over 6, which is too much. And actually, pi over 6 is too small. It's not in the interval. So this has very few answers. So do I think it should have only 2 answers? I kind of do, because the period of the given function, right? So b is 1/2. So the period is 2 pi. So we're getting 2.5 periods because it's 0 to 5 pi. So 0 to 2 pi is 1. Well, whatever. We're getting 2.5 periods. So you could have gotten 3 solutions, maybe because all 3 fall in that 2.5 periods, or you could just get 2 solutions. So I think 2 solutions is totally fine. So now we got to do our kind of like back substitution, I guess you might call it, where we don't want to solve for U. We want to solve for X. So let's make our substitution. I'm going to rewrite this as x over, what am I doing? X over 2 plus, not plus pi over 3, I'm going to say 2 pi over 6. Common denominators save you a lot of time and effort. So this is happening. And then, so I need to subtract 2 and then multiply the numerator by 2, which really, so when I multiply by 2, what's going to happen is this 2 will end up like in the numerator here, but it'll cancel with this, just make the denominator 3. So I'm going to subtract 2 and make the denominator 3. 5 pi over 3, subtract 2, and make the denominator 3. So these should be our x values, and I am inclined to check those on the calculator. So I'm going to do that. I think you should check everything. It's I know it's a pain in the neck, but it's like so worth it because you just find your mistakes. Like why would you not check? Like it's almost like I don't know, like you might almost think a teacher would be like, you're not allowed to check, because it's almost like checking feels like cheating. If you really know how to check, like you're never going to get anything wrong, or at least you'll never get anything wrong that you didn't know you were getting wrong, which you know, it's probably really frustrating if you just know that it's wrong and you don't know how to fix it, but like, so be it. All right, we get the answers that we expected. So nice. I'm going to go back in and I'm going to solve the next problem in the same video. So, well, assuming I can get here, every once in a while, it like kind of refuses to bounce back. All right, this one, I can, so because of this, I'm expecting there to be just like a ton of answers. Because you basically it means like every quadrant is like in play because you're going to square anyway. So let's see. I'm going to do U substitution first, I think. So U is 2 pi over 5 times x minus 2 pi. So if x is equal to -5, then u is going to be, so that's -2 pi minus 2 pi, so -4 pi. If x is equal to 5, then u is going to be equal to, so okay, 2 pi minus 2 pi, so 0. All right, it's a weird interval, kind of. I'm going to divide by 6 and say secant squared of u equals 2. So I'm going to make that cosine squared of u equals 1/2, because no one likes to think about secants and cosecants. Like, let's all be honest. As soon as you see them, you flip them over and you solve kind of the reciprocal problem, or you should. Or, well, I mean, I'm not telling you have to do that, but I'm telling you I think you should think that way. There we go. All right, so square root is going to give me, so either cosine of u equals radical 2/2, or cosine of u equals -√2/2. All right, so what can we do with this? Well, I know that u is all the pi/4s because of the √2/2 that I'm seeing there. So I'm thinking, like, initially, that u will definitely be all of the pi/4s. Pi/4, I don't know why I'm skipping 3 pi/4, 5 pi/4, and 7 pi/4. The problem with all of those is that absolutely none of them are in the interval that we want, right? So we're looking for -4 pi to 0. So what I'm going to do is I'm going to start off, maybe I'll do these, I'm going to write them in reverse order, just like, I don't know, or, so I never really know if I should, like, these are, you get to experience my doubts. So I'm going to go, like, the first one, I'm gonna go in descending order instead of ascending. So the first one that's going to work is I'm going to subtract 2 pi from this and get -pi/4, and then just keep subtracting. -3 pi/4. What are we going to stop at? We're going to stop when we get to -16 pi/4. So -5 pi/4, -7 pi/4. Keep going. So it's going to be -9 pi/4, -12 pi/4. What? -11 pi/4. It didn't really make sense because I know none of them should reduce, and like 12 would reduce. -13 pi/4, getting close, and -15 pi/4. Okay, and if we tried to go further, we would be less than -16 pi/4. So these are our initial answers. They're in descending order because -pi/4 is actually the biggest one. So let's see. Now I gotta make my switch though, right? So I have u, but I don't want u. I want this. So what kind of work can we do to make this easier? First, I'm gonna rewrite 2 pi as 8 pi over 4. So 2 pi over 5x. Why would you auto? Why? Okay, over x, and then minus 8 pi over 4 equals, copy and paste time. What a blessing it is to be able to do that. Not even kidding. It's like, it's the little things, and that's like a little thing that makes just a huge difference. All right, what are we doing? We're going to add 8 to every numerator, and then multiply by 5, and then divide by 2 pi. So dividing by pi is going to knock all the pi's out. There's not going to be a pi in my answer. When I divide by 2, it's going to make all the denominators 8. So I'm going to add 8 to the numerator, multiply by 5, and then the denominator will be 8. That's my plan. I'm going to go for it in one shot. And you don't have to do this. You could always, what the? That's a weird little artifact there. I'm going to delete that. Those are, so because of how weird this year is, I had to, well, like, there's no yearbook basically. So what I'm doing is I made like a little thing, and I'm writing a little thing for everybody. So that was the, I don't know why there's a screenshot of that or how I even got that screenshot. But that's what that was. Those are all the ones that I've done so far. And I got so many more to go. But anyway, what was our plan? Our plan was we're going to add 8, multiply by 5, and make the denominator 8, I think. So let's see how this works. If I add 8, I get 7, so 35, and then over 8. If I add 8, I get 5, so 25 over 8. Also, oh yeah, no, they're positive. If I add 8, I get 3 times 5 is 15. Oh, you know what was weirding me out is that they're getting smaller, but they're supposed to because these are in descending order. I was like, this doesn't make sense. So this will be 5 over 8, because I'm adding 8. So now I get negative 5 over 8. I get negative, what am I doing? I'm adding 8, multiplying by 5. Add 8, multiply by 5, negative 15 over 8. I feel like one of these might be wrong. Let me see here. I added 8 to get 1 times 5 is 5. I added 8 to get negative 1 times 5. Added 8 to get 3, negative 3. Okay, so maybe not. Add 8, and then this, and then add 8 is negative 7, negative 35 over 8. And one of these is definitely wrong. I think it's this one. Add 8, you get negative 5. Multiply by 5, you get negative 25. So there's this really nice symmetry in the answers, which I guess you would probably expect. Well, maybe. You like sort of expect it because it's secant, and secant's an even function, but then it's shifted, so you're not really sure, but it's shifted by 2 pi, which is like, you might as well not even shift. So I think that these are the answers. I'm definitely gonna check. Let's see. I mean, they worked out really nicely, so I feel like it's probably the answers. So let's see. I want to solve 6 secant of 2 pi times x over 5 minus 2 pi. Then I have to square that, equals 12 for x, but we have to be between negative 5 and 5. So negative 35, negative 25, 15, 5, and then 5, 15, 25, 35. Got it, man. This system works, which I like because it's like unnerving. Like it seems like when you're doing trig equations that there's just like too many options. There aren't too many options. Well, maybe there are too many options, but like have your method, use your method, it will work. This is a method that definitely works. By the way, you could have done like on this step, feel free to do like 3 different steps. Like add your 2 pi to everything, multiply everything by 5, then divide everything by 2 pi. There's nothing wrong with that. It's just like so much writing. And it's so algorithmic that you can just do it. Like you don't really need to show all the work, but you can. It's never wrong to show the work if you need to show the work. So I'll be back in the next video doing more of this. So see you there.